Good morning, everyone, and welcome back to another episode from the Scale Up Thursday series. My name is Rashmita, and I'm the event planner for Microsoft Reactor India. I'm here today joined by our very own host, Vinayak, and of course, our special guest speaker, Ganesh. But before we start the session, I would request you all to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat section is open throughout, and we do encourage you all to participate. Our speaker will answer all your questions during the session, so please feel free to drop all your questions in the chat section. With this, thank you all. Enjoy the session, and I would now like to bring Vinayak in to the stream. Hi, Vinayak.
Hi, Rashmita.
Morning.
How are you? Good morning.
I'm doing
Cool.
good.
So my name,
How are you?
yeah, I'm good. I'm good. Hey everyone. So my name is Vinayak Hegde. I'm the CTO in residence at Microsoft for Startups, and today I'll be leading you through the discussion with Ganesh. So a little bit about me. So I work very closely with startups across the world to help them actually uh, implement their business strategy using Azure and also help them scale their product and tech uh, uh, using open source and Microsoft technology. Right. So with that, I'll bring on Ganesh, who is our speaker for the day. So Ganesh is the CEO of FluxGen. Hi Ganesh, how are you? Good morning. Ganesh, you're on mute, so you'll have to unmute yourself.
Oh, I'm sorry. Hi, Vinayak. Very good morning. Thank you so much for having me on this show. I mean, quite excited.
Yeah, Ganesh, could you tell a little bit about FluxGen and about give a little short intro about yourself as well? Like maybe also then we can maybe start off going into the presentation maybe about what is the so I think the world is changing really fast, and I think especially when it comes to climate, I think there are several different challenges, right? And one of the big challenges is actually other than the temperature, but also water, right? I think the water profile and everywhere, I think whether it is like water coming into the rivers via snow melt or rainfall, or even storage, I think it's a huge problem. So I believe that your company solves this problem, especially in an industrial scenario. So I'm like very excited to have you, and maybe let's start off with maybe a short intro about yourself and your company and the problem that you're trying to solve.
Sure, Vinayak. I'll try to start with my very earliest journey. My father says there are more than 1,000 lakes in Bangalore before I was born, right? And by the time after I was born, I think there are less than 100 lakes today, right? And the earliest times that I saw water was we had a well at home, and we used to consume water from that well, and this was when I was in my earliest days before going to school. By the time I went to start going to school, the well dried out, and we started getting water tap connection at home. So we actually were able to get water on a regular daily basis. But by the time I went to my middle school, actually water was not coming on regular basis, because of which my father was taking care of the water affairs at home, put a tank at home. And by the time I went to my high school, the water was not able to fill the tank or a tank, so because of which we had to get a sump at home, right? And by the time I went to my engineering, while I'm doing my introduction, I went to RB College of Engineering to do my engineering in communication technology. We also had to get one more tank at home because the water was so infrequent. You can see that how water has depleted or availability has changed. And by the time I went to do my master's at the Institute of Science and later at work at General Electric, he also started procuring water from tankers. This is how I've seen my how water I've seen in my life, and if this rate continues, my son will probably consume water from capsule as well. Consider the fact that we have water from bottle today. So this is how I've seen water. And if that's the case for water, for my father, who is a resident of this country, what do you think would be the challenge for industries? Because water will be prioritized to my father's and likes than for industry. So that's exactly what we are trying to solve, because industries are in massive and imminent risk because of water crisis, and we believe we are well positioned to solve that.
Cool. So, Ganesh, do you want to share the presentation as well, and maybe let us walk through that as well, like the specifics of the challenges as well, in a little bit more detail as well.
Absolutely, Vinayak. Just allow me to share my screen.
Sure.
Uh, yeah, as I said, if there's a water crisis happening already, and water crisis is not going to happen in the future. It is already happening. So you can sense that industries are in massive risk, and that's what FluxGen is trying to solve. I'll go ahead and share the specific problem in my next slide. Okay. Yeah. Oh, sorry. Oh, sorry. There's some glitch in my uh, presentation. You can. Hello.
Yeah, Ganesh, we can hear you, but we can't see your presentation yet.
Oh, is it okay?
We
There is
saw
some.
it for a little bit, and then it kind of disappeared. Can you try sharing again?
Yeah, I'll share it again. This minor glitch. I think that's why we all have jobs. There's always need to develop new things. You can see it now.
Yeah, it's just coming. Yes, I can see it now. Yes.
Not able to change screen. It was all working fine earlier. Okay.
Yeah, I think maybe it's a little slow. Uh, and yeah, it's gone again.
Okay. You can see it now.
Not yet. I could see it for a brief moment earlier, but it's kind of disappeared now.
Okay. I've been trying again and again. There is some issue with the.
Cool.
Okay. You
We
can
are,
see now.
yeah, I can see it now. Yes.
Okay. So, as I said, we de-risk industries from water crisis, and we help industries in identifying three major risks. One is financial risk. There's
Mhm.
the cost of water is increasing drastically over a period of time. There's a cost associated. I mean, because today water is also procured from tankers, which is around 5x times the 5 to 10x the cost of water from other sources. That is one cost, and then there is a cost associated to pumping, purifying, recycling of water,
Mhm.
which is basically anywhere from 10x to 100x depending on the type of industry. Like this is a cost because of energy associated to water. That is there's a chiller which consumes huge amount of water, and also at the same time energy consumed to manage this chiller, and there's a boiler which is again consumes huge amount of water to heat the water. So that adds up to another 10x the cost of water, and there are various other chemical dosing other that adds up to the cost. And not just that, today groundwater extraction itself you have to pay for it. So there's a additional cost associated to paying for it, right? And then there is a cost associated to treatment of water. So if you have any water that you're consuming today, you have to treat it. So that means that there is a 2x to 5x the cost of water which is involved in treating. Treating again I mean, sewage treatment, effluent treatment, depending on the type of customer, the cost can vary. Like, for example, one of our customers buy water at 100 rupees per kiloliter, but the treatment cost is almost 1000 rupees per kiloliter. So that's
So
how
it's a factor. So it's a you're saying the treatment cost is almost like a factor of magnitude of almost like 10 times or so of just like consuming the water, because I think it's is it mandated by law? Is that also the challenge?
Yeah, I mean, today it is required all industries have to do zero liquid discharge. I mean, because if you're consuming any water, that might actually come from sources which can also get polluted if the industries are not practicing zero liquid discharge. I mean, this is because today groundwater percolates and it actually becomes part of our source, right? So, zero liquid discharge is mandatory today.
Okay.
Okay.
Ganesh, can you see if the slides are working now? Maybe we can go to the next slide.
I don't know. This is a bit of a tricky thing that I not able to change slides.
Uh, so can you just go to the bottom left and see if you can you can see that there's a hover, and then maybe try using the next slide by that.
Yeah.
So we lost the slides again, Ganesh. So we might have to reshare.
Yeah. Okay. I'll do the entire screen so that way.
Yeah, yeah. Maybe try sharing the entire screen. Maybe that would help.
Is this working?
We Yeah. So maybe put it in presentation mode, and that should kind of help. We
Is
can
this
see all
fine?
the. Yes, we can see the entire slide set, but can you just try putting it in presentation mode? So maybe that might help.
I did that. Again, that's the problem it is creating. It's trying to go to another. Is this working?
Yeah, so let's do this. Let's maybe have this screen, and just if you can hide the left hand side pane, we can go through with that. So we can work with this. Yeah.
Yeah, yeah, yeah. I'm just trying to click the left pane, but it's not happening. I'm sorry. I think I'll try to do cover up with my presentation. Okay, by my talk. So as I said,
Yeah.
there's a
Yeah.
financial risk associated to the cost, and then there's a business continuity risk, which industries are facing because of shortage of water. So what I
Mhm.
mean to say is that because water tables are depleting, there's a business continuity risk. You also touched upon a very important part in the early part where you mentioned climate change is as much as like a water crisis, right? So there's a direct connection with climate change and water crisis. Because we live in a warmer planet, I mean, unfortunately, we are approaching that 1.5 degree. There's a change in hydrology and evapotranspiration in this one, because of which there's a change in water cycle, because of which the places where they used to get less, rainfall is now becoming drought prone, and people in some places there is a heavy flood. So this directly affects industries because industries consume huge amount of water. So that is a risk that the industry were not able was not was there prehistorically, but today it's a very important pertinent risk. And then there's a compliance risk, because water crisis directly affects our country by up to GDP by up to 6%. Government has actually made strong regulations, one, and also enforcement, to be honest. So one is a CPCB regulation, which is Central Pollution Control Board regulation, where according to Water Act of India, you have to monitor water at key location in a factory. This is also to ensure there's a responsible water consumption in industry. So then there is also a requirement to monitor water treatment plant. All this today are also now required to be done on your telemetry and IoT and cloud-based systems. So that's where the regulation comes in. And then is CGW. As I said, the Central Groundwater Authority has made it mandatory just about 6 7 months back that all groundwater extraction today has to be monitored and you have to pay for it. So you have to use a IoT based system and monitor and report it to CGWA thing. Not just that, you also have to ensure the water consumption, water withdrawal rather, from your groundwater has to be reduced by up to 20, minimum 20% in 2 years time, or increase the groundwater levels by 20% through various intervention. So this again makes sure that industry have to be very cognizant of water consumption. There are various other organizations like FSSAI, which promotes food security, safety, also ensures that there is has to be water responsibly utilized. So that's how they would get certification. The last one, but not the least, is BRSR, which is very important today, which is business responsibility and sustainability reporting. So this has come in enforcement mandatory from this financial year. So what it means that is, if I'm buying this shirt in the market, I would also know how much water was required to make this shirt. Or if I'm buying even the phone or anything in the market, I would be told how much water was required to make this. So this way, consumer is getting to know how much is the environmental footprint, even including carbon and energy is required. So this way, a consumer is aware of this, and this directly puts pressure on investors also to make sure that industries have to consume less water. Because when I go to the shop, I would always like to buy something that is environmentally friendly. So this indirectly put indirect investor pressure on industry. All these three major risks. There's also reputational risk and other risk that adds up to the three risk, which makes it water management a mandatory thing. And it also is important to use digital tools, right? So coming to anything you have in particular, Vinayak, on this slide or this part of the presentation. Hello, Vinayak.
Sorry, I mean,
Vinayak, you're on mute. Yeah.
yeah, sorry. I realize I'm on mute. So yeah, so I just wanted to ask you, like, maybe we can talk a little bit about the solution. I think we know that, I think using processing and compliance risk is there when we are using water, especially in a warming planet. So maybe let's talk a little bit about the solution as well.
Sure. See, our belief is just like how water as a liquid is transparent and clear. What if you make the data of water transparent and clear, and build solution on top of it? Can you solve water crisis? We believe yes, right? I mean, because what doesn't get measured cannot be managed, right? So
That's
what we do is we identify leakage, wastage, excessive usage, and water quality to make sure that the water usage can be reduced by up to 30%. So how we do it is basically we use IoT and data science. What we do is we monitor flow, level, pressure, various water sensors in an infrastructure, from input to the output and in consumption, and I generate high quality reports which are required for compliance, that is Central Pollution Control Board and even groundwater related regulation. Give prescriptive alerts on our platform, so that way you are able to identify what are the action that to be taken. What would take like a day or week or months to get to solve the problem, you are able to fix it in less than 20 minutes time through our dashboard. Since we have complete understanding our infrastructure of water infrastructure, we are able to uh, make sure that if there's a downtime in any of the water system, especially wastewater management system, so because if there's a downtime, they have to transport this water, right? So we've been able to do that through our platform. Maybe I'll show you an example of one of our customer that would help.
Yeah, so I think, yeah, let's talk about I think real world use case, because that would actually give a sense of how it works in real life. So maybe, yeah, let's maybe talk about a case study, with a particular customer and how they are actually using your product and solving this particular challenge.
Surely. So I would like to pick one of our customer who has been benefited in many ways. One is DKNMH Hospital. So this hospital is in Coimbatore. Even our Mysore Kings used to get treated there. So the hospital, had a belief that if they are, I mean, the main goal of the hospital is like to heal the world, not to harm the world. So they were very cognizant about managing water, both from the consumption of amount of water that they're consuming, and at the same time making sure that they're not sending any effluents. Right. So we deployed our solution with putting our monitoring points at more than 15 locations. We're able to ensure all the water that is consumed to the input output at various locations, whether it's dialysis, kitchen, laundry, or whatever you would call the consumption that happens in a hospital. We were able to manage. We had given a dashboard that would generate analytics and alerts and give notifications. So notification include water leakage, water wastage, excessive water usage. All those things were actually able to come through our dashboard, right? By this, the hospital was able to reduce their water consumption immediately within the span to up to 10%. So what it means is the amount of water that they were getting from tanker was reduced. So there was a financial saving, as you can see, and about 16, 17 lakhs worth of saving. And not just that, they were able to take care of their risk associated to compliance, their central groundwater related compliance or central groundwater related compliance. All those things were taken. If not doing so, would have costed them minimum 10 lakhs per year fine. And at the same time, they were able to achieve their sustainability goals, which is the main reason why they went into it, because they realized that they were here to heal the world, and even making sure that they consume least amount of water is something that they were looking from their ESG point of view. Not just that, they were able to achieve these goals. The hospital won the CII National Water Award, which is like the Oscars in water management in India, right? And also they were able to get the US Green Building Council Platinum rated and Indian Green Building Platinum rated. Only hospital in the entire country to get such a recognition for their work. And they achieved their water score of 14 out of 5, where the average is 10 out of 15 in the global level, right? So that's how we are able to help this hospital. Like this, we have many other hospitals as well. Let me even go a little further. Vinay can trying to help how we did it.
Yeah,
Yeah.
so maybe let me walk us through this diagram. And again, like there are many different components. So if you can tell us, how do you walk through this diagram? What are the different? Because I can see that there are a bunch of sources of water and bunches of places where water is used and maybe purified or treated, and then I think also recycled in some sense.
Correct, correct. So yeah, right. Basically, there is water coming from multiple sources. There's borewell one, borewell two. There's a tanker water also coming in. Rainwater harvesting is generally practiced in most places in India today, or at least in the process of that. And there's also city also provides, municipality also provides water. So we're able to understand that, and then understand there are some amount of water which is directly that you can consume. That is raw water. Some water you have to soften it because you have to reduce the hardness, and then there are some water which has to be RO treatment, because that water is required for some specific requirement in kitchens and other this one. So basically, we've been able to put this, and we are able to monitor at all this key location. So it is not specifically for a hospital. I'm saying hospital was a generic case, and this is a generic. This water balance chart is a generic case for any facility you can look into. So we put up these IoT devices in all this 22 different location. You can see this, and we monitor water flow, water level, water pressure if required, if it's underground pipe to understand, or water quality also in this place. So the droplet doesn't measure mean only water flow or quantity. It means it can be water flow and water quantity as well as water quality. So to give you an understanding of how it would look in real life, is that this is how we put up these devices. There are various kinds of water flow meter, level sensor. I have shown you mostly the water flow meter. On the top left is electromagnetic flow meter, where depending on the electromagnetic feedback, you'll know the flow of water, which gives us a non-intrusive way. On the bottom right, you can see in a more advanced flow meter where we have put up water flow meter onto the pipe without even cutting the pipe.
Okay.
It's just a clamp on kind of thing. So ultrasonic waves goes in and returns back, and change in the phase velocity lets you know the flow of water. So like this we have been able to deploy. So this fairly a bit about how our customers generally use our product.
Yeah, so I had a follow-up question on the earlier slide as well, and also maybe this slide as well. Is that how much of the water typically is like I can see the STP and ETP. How much of the water typically is like recycled, and what is like the quality of recycling? I mean, do you use it like for maybe maybe like this this sewage or toilet system, or do you is it like purified to an extent that it can be used as like drinking water or industrial uses? So I just want to know, what percentage of water is recycled, right? Because that has a direct impact on the environment as well, right? Like, because you're reusing the water, which means that you're not taking water from the environment, which means I think there is water in the water table as well, which is not getting consumed. So actually depleting your water resources much lesser, which gives them time to kind of getting replenished as well, right?
Yeah, a very pertinent question you asked, Vinayak. So yes, I think almost all the water that actually goes to the water treatment plant, if assume an industry is consuming overall 100 kiloliters, just for the sake of example, at
Sure.
least 60 to 70% would be get will go for a water treatment. Rest of it will be either consumed as drinking and various other process, but almost 60 to 70% water actually gets in the treatment, and all that water has to be treated. So since it is a requirement today, zero liquid discharge, you can't be discharging any water which is not treated, right? So when you
Okay.
say zero liquid discharge, you are zero effluent you are discharging into the environment. So that way all this, and to the question on whether this water will be utilized, again, yes, I mean, part of this water if is depending on the treatment technology. See, because the water treatment is to get to the drinking water capability is very expensive. It is not yet practiced in our country yet, but it is practiced in countries where there is a very scarce availability of water, like Middle East and other places. But today, that treated water is used in various ways. In, like for example, the textile industry, they use many of most of this water again into their facility for various processes. But if it's a food processing and beverage industry, the treated water is not up to the quality of producing food grade materials, food grade stuff. That's why it is generally used in your garden and various other places where this water can be utilized. I mean, see, there is a biodiversity component has to be maintained in any facility today. I mean, I see that in all Microsoft facilities, of course, have managed it. That like that, even all industries today practice biodiversity in terms of having more trees and other things. So that water comes through this treated water. So no fresh water is generally utilized. Fresh water is generally used for consumption, right? So treated water is utilized for all the trees and plants. So that way, almost all the treated water is utilized within the fence itself. So if the water quality is good enough, that can also be used for recharging your groundwater as well.
Yeah, that is excellent. Ganesh, we have talked about the problem and how we are solving this problem in a unique way. Especially, I think what was fascinating for me is like in the next slide. Actually, you talked about the different sensors and also the fact that using like you talked about the the sensor being non-intrusive, right? Which means that like, you don't have to change existing infrastructure to actually kind of use your product, and that is like a huge win, right? Because the amount of time it takes for installation hopefully like goes down, and also it's very non-disruptive to what is already existing, right? Like you don't have to like cut pipes and do that kind of thing, which is fantastic. So I maybe also I want to talk a little bit about maybe the team that is actually building, and maybe a little bit about your background also. And I think you have had your journey, and then how you kind of maybe stumbled upon this specific problem, and like little bit about your team and how you how they're kind of coming together to solve this problem. If you can talk a little bit about that, that would really help. And then maybe like we can do a slightly deeper dive into the tech as well.
Surely, surely. Yes, I mean, I have included the team slide and my present about myself, as I see this is a very can be useful to the audience. So yeah, a bit about myself. I mean, it's a single founder company, so I could only put my picture in this, but I have my colleagues which are doing the most of the work in the other slides. See, as I already said, I did my education in telecommunication engineering in RV College, and I did work in ISRO for a short duration. Had strong interest in aerospace, and then I did my masters in Indian Institute of Science, right? And then later on went on to join General Electric in aerospace business because I was interested in that, and then I ended up building a solar intelligence company. Was just like how I have water. I earlier built a solar intelligence company which used drone analytics and various other sensor to identify inefficiency solar, and this company was called AirPro. Of course, this company became a leader in India and went across three other countries. And this company was acquired by a San Francisco-based company called Drone Base. So, having had my share in building a solar intelligence company along with my two other co-founders, I decided to build a water intelligence company today, and that's mainly possible because of my strong team. So Deepak himself had worked in energy business for more than 12 years in L&T. He was managing energy meter business for whole of South India. One of the best employees for nearly 6 consecutive years. I also was a I also used to teach at the Institute of Science, and I met Deepak as my student in a course that I used to offer, and I somehow got him to my company to work with me. Of course, Suraj heads engineering and technology, and Suraj has worked in NVIDIA and other companies as alumnus of NITK and University of Science. Also worked in a startup called Pachshot. Is very was very keen on solving problems on environment when he joined. Bob actually heads the sales. He had worked in Blue Star Campbell Rao, which are all again energy intensive work. So everybody, most of us have actually saw that there is a transition in energy. Now the next is so important is water, right? And Vasanta, of course. So I mean,
Yeah.
I think we'll soon start realizing. So this team would even become bigger as we are hiring a lot of very interesting people. So Vasanta
Sure.
happens to be from. So yeah, I mean from IIT Madras, she had interned, and university topper from Anna University, and Sham again, and Moni had worked in the world's largest water management company called Veolia, and he has joined our journey. Yeah, I mean this
No,
her team.
this is fantastic. I mean, it's interesting. Like you have worked in like climate tech, electronics, and then also maybe climate tech from solar. And now I think you're coming up with this in the same thing. So you're basically like using your background to, kind of solve problems. What? Because mostly I think when we talk about climate tech, I think most of the time I think the companies that we come across are either solving energy related problems, or like like solar and green energy, or they are doing like carbon capture or carbon credits related work. But I think you are one of the few companies that are actually solving the water, which is actually going to become a more and more graver problem. So maybe let's in the next slide maybe talk a little bit about the architecture, and how you are kind of sensing data, how is it getting collected in the cloud, how it's getting stored. So can you just walk us a little bit through that?
Surely, when I just want to add one line before I move to the architecture, since you mentioned about climate, they said that if climate change is shark, water is its teeth. So you can imagine the biggest
That's an
problem
interesting
that
saying.
we. So I mean I encourage many audience who are here to actually take up careers in water, and we need more people solve it. Okay, and yeah,
Meanwhile,
let
I
me.
think just before we go on to the architecture, mostly like housekeeping. So, we I just want to talk about Founders Hub. Founders Hub is, as you've seen in the beginning, the portal where you can apply for different kinds of credits, and We have advisory for startups. I think Ganesh has also benefited from that, and there is also a reference email that is scrolling at the bottom of the screen. So if you want to apply, and if you come across this through a program, just use the reference email ID. And of I think Ganesh is talking about very interesting stuff. So if you have any questions about the technology, about the problem itself or the solution, or anything related to what we have talked in climate tech, please leave your questions in the chat, and then we'll take those questions as we go through this presentation. Yeah. So with that, I think Ganesh, let's talk a little bit about the architecture, and how all of this happens in the background, with all of these different sensors and data, and also there's a cloud and data science component to it. Yeah. Over to you,
Yeah,
Ganesh.
absolutely. Yeah, I mean, should definitely thank the Founders Hub, including you, of course. You have been such a great support to us. We have a great stack today, and if it is solving customer problem, we've gained a lot from you, Vinayak, and a lot of other people in Microsoft who has helped us both on the technical front and on the growing the business front, right? So let me talk about the architecture. As you already saw how our solution works, the left hand side of the architecture is more on the hardware side, on the right hand side is on more on the software that our customers generally use. So basically, you can see there's a water flow meter, water level sensor, water quality sensor. We also actually monitor energy consumed by water infrastructure as well, right? So that's how we have been able to help our customer, and we have been able to develop our own IoT in-house IoT hardware that takes data from all the sensors. That is water flow, water level, water pressure. Most of this data comes through various communication interfaces, whether it is 420 or LAMP, or whether it is a Modbus communication, or sometimes it's a pulse output. Their heart communication also is used in some energy water flow meter, which is from Industry 3.0 based communications. What we do is we convert all this data that can be shared on a wireless sensor network, or on a onto it directly onto the cloud through a GSM module, 4G, 2G modules that sends directly to Azure cloud. And of course, I'll have a detailed slide on how the cloud part is there in my next slide. From this, we all our customers use the data on their web dashboard, on their mobile phones, on their various other. I mean, we also have desktop application. So generally, the ground staff use the web mobile application because they have access to mobile phone more than computers. But the production head, maintenance head, and facilities head, EHS, and other managerial role uses the web dashboard. So, in general, most of the problems before it comes to the issue on the web dashboard is solved in the mobile itself. The alerts are generally generated on the mobile, so that the ground staff plumbing team can actually quickly take care of actions, right? And also another thing is there are many industries which already have a industrial monitoring system, their building management system. So we've been able to integrate through our own backnet communication as well. So besides that, we also give APIs to industries which have everything: water, energy, transportation, parking, and various other facilities that they have in their one shot. We give APIs that they access. So this is a this is a overall architecture. I'll go into the depth of Azure through this.
So Ganesh, before we go, I just want to take one audience question. Rashmita, if you can show that on the screen. So JV is asking, how is excess consumption defined? So is it like based on the industry? Is it based on maybe the water usage profile? How do you define excess consumption, right?
Yeah, so from the compliance lens, if I have to look into it, every industry has a specific consumption limit for what they produce. For example, if you consider a dairy, like the milk dairy production unit, for a million liter of milk produced, they are not supposed to consume more than a million liter of water, right?
Okay.
So that's a benchmark at a very high level. They have also made a consumption limit for each processes in this whole balance chart that I showed you. So that is a from a compliance from a Water Act of India perspective. But every industry by themselves have their own internal limit because they want to exceed the compliance and they want to become leaders in water. So that is specific to each industry target. Like for example, Microsoft has come up with your target, right, to become water positive by end of 2030. Like that, every industry have come up with their production facility have come up with becoming water positive by so and so year. So with that, excess water consumption also becomes part of becoming water positive initiative. So that way, each industries today have their own limit for water consumption in each process, and they're also trying to come up with way by which they don't even use water. I mean, you might have been to many airports; they would have seen waterless urinals. So they are replacing the excess water from low water to no water. So yeah, that hopefully answers the question.
Yeah, so I think what you're saying is that different level of compliance. Obviously, there's this legal compliance, which is like uh, slightly maybe lower bar, but and I think industry level you have benchmarks as well for every process and every um, every process and also every particular uh, vertical as well that are benchmarked. So um, yeah, so based on the input, I think they're doing, and I think yes, I think based on what you said earlier, I think a lot of the water is also getting recycled, and when it's recycled, also some of it is going back to the groundwater, which is very heartening. So in some sense, the idea is to get to like when we say excess, idea is to get like as close to, I would say maybe zero consumption might be a tough goal in most cases, but I'd get as close to that as possible. So basically, like leave no trace kind of mentality is what we are encouraging in that sense, especially for like commercial usage where there is a lot of water usage in any kind of industry, because the lower I think the water usage is, I think the lower the cost of treatment as well, right? As you said, Ganesh. So there is a commercial incentive also for industries to kind of do that in addition to the legal and the environmental compliance that is there as well.
Absolutely. So I think all those things is not everything is designed to nudge you people to reduce their consumption, and so there's a behavioral aspect that comes directly when such incentives are made.
Cool. So let's maybe go a little deeper into the architecture. We have about 15 to 20 minutes, so we'll quickly go over that, and then maybe we can do a little bit of demo.
Sure, Vinay. So I'll go into the overall Azure part or our cloud part rather. So as you can see, there's an IoT sensor. The IoT sensor could be a GSM module or a LoRaWAN gateway, or it could be Zigbee gateway. So various networks. Of course, we are not using much of Zigbee anymore, but still we have been able to use various wireless sensor networks. So this IoT sensor sends the data to the cloud. So what we use is device provisioning service, which ensures that the our devices, authenticated device, are able to send data to the cloud and ensure, of course, we are using the MQTT protocol all through to ensure Azure IoT Hub is able to stream all the data from our IoT nodes, basically authenticated device. So we don't want any non-device which are not our devices coming in, and then this data is pre-processed at your stream analytics, right? Analytics job where we are ensuring there is some amount of, I mean, with respect to every 5 minutes data is coming. In our case, we take data every 5 minutes, and we label the data depending on what is the data coming from, whether it is coming from a chiller unit or is it coming from a groundwater setup or it is a rainwater harvesting or various other labeling it. Part of the data, all the data that comes actually goes through both the Azure Cosmos DB and as well as our blob storage, because raw data might be required at a later point of time, because some of this can be very compliance related things where we have to store this data for nearly 3 to 5, in some cases 5 years as well. So
So this
that
is
is
mostly
stored
like
here.
for, so this is like you're saying the raw data is for the audit, and actually the processing and the querying is happening over the Cosmos DB, right?
Yeah, all the thing happens in the Cosmos DB, as you rightly said, and we have realized it's the most fastest way to develop our application, and it's a very secure, and all our SLAs are honored, ensured in this way. And of course, we use function apps to make sure that for our notification services, whether it's a prescriptive alerts or whether it is a any suggestion that we can give to our customers on our dashboard, is going through this function apps. Any of the learning algorithms, analytics, all works there. And of course, this API server apps, the app services ensures all our APIs to send it to our end devices, whether it's a mobile, web, or desktop, is done through that. Of course, this could have multiple services to ensure the traffic and load balancing can be done. I'm sure for simplicity's sake, I've put one there. And all our APIs are, of course, accessed on mobile and web. We are using workspace web for our web application, and of course a desktop also we provide. So there is a part of our application for large clients, very huge clients. We have like 100 slides sites or 50 sites, that range. We also give it customized desktop application
Okay.
to any, because if there is a customer who have multiple sites they want in one dashboard, and
Okay.
that's the level of customization we are willing to do, though we are a product company. But most of the backend remains same, right? And of course, for notification we use Firebase messaging. We used it in the past, and even before migrating from our previous, and we found this to be very comfortable to use. So that's helping us out. Firebase messaging is helping us out in that way for mobile alerts. Yeah, web publication subscription services from Microsoft Azure is something that helps in giving notification. The web sockets able to connect to it and able to give these alerts. We have also enabled that through desktop application as well. So yeah, I mean, of course, there's a lot of other new developments happening where our architecture, but so far this architecture is helping us make sure all our customer commitments have been achieved.
So, so when you're talking on the API services, you're saying that obviously you have the your own mobile and desktop app, and it's interesting that you are actually also building custom faces for multi-site kind of scenarios. But I think you mentioned that earlier in the talk that you are also integrating with existing solutions when it comes to when it comes to actually like building management solutions or industrial site management systems also too. So water is like in that sense like one of the inputs along with like maybe other energy parameters as well, right?
Correct, correct.
So,
You are right.
so
I should have
API
also
allows you to do
included as
that.
an external API from this dashboard. So from
Okay.
this, so there could be API services can also go to external apps. Like of course, FluxGen has been selected for Amrut 2.0, which is a government's initiative for managing water for smart cities. And in this case, I mean, one of very few companies in digital space selected, and we are honored to and privileged to have been selected. They have given us, so in that case we are also giving this command control and other facilities
Okay.
smart cities would have through our app services thing. And as I said earlier, some of the customers also have for example, in LCT, Electronic City Township Association, where Wipro has built the what do you call, the dashboard for smart city of electronic city. So we've been able to give our APIs for them to integrate into their web dashboard, which comprises of parking, energy, and water, and various other sources of water. We are been able to easily integrate to their dashboard.
Interesting, right? Like, so, I mean, even on the storage part, also, one, I think you're like using the Azure Blob storage for the raw data, which is like used for audit. And I think for the querying, because I think most of the data that I've traditionally seen that comes from IoT devices is in either binary format or it's typically also nowadays in JSON format. So then querying
Correct.
it and storing it becomes really easy when you use Cosmos DB. And also, I think the fact that you might also have deployment in other countries, so you have a geo replication also, right? Like if you're kind of onboarding a large customer which has like a multi country kind of setup, and then each of them might have different compliance requirements, be different reporting requirements. So I think having the same backend that is like geo replicated becomes really easy as well.
Yeah, absolutely. See, the thing is, most of our clients, are already using Azure as for their various application. In fact, when I talk to many of them, we talk generally on Microsoft Teams, so that also gives them that security viewpoint that we are using a very secure cloud. And over and beyond, it also helps for their adoption as a not a barrier. Of course, there are other clouds which are great, but we find all our enterprise clients whom we work, they have strong confidence in our stack, and the fact that we have been working on these secure platforms to ensure that data is well protected. And of course, the blob storage, as you rightly said, it is important because we have to store it for if there's an extension of contract with a client, we have to store for longer duration. We can always put in write a small Python code and send the requested services to our Cosmos DB as and when requested. Depending on so there's also this field, there's an evolving compliance need because of a rapid water crisis that is happening. So yeah, right now this supports, but we are expecting more intervention from policy, which for which we might have to do some more development.
Yeah, no, I think water crisis is actually not just like an Indian problem. I think though you're building like I was reading recently, like in California as well, which is the home of in some sense tech in some sense. There also, I think there is like depletion of water and in the water table, and I think there are forest fires, and there is especially for farming also they have to ration water, and especially like some large cities are like very close to desert. Like I mean, the most famous example is probably in the US is like Las Vegas, and they have like very stringent requirements when it comes to like using water as well. So yeah, it's a problem that is not very specific to India. It's like happening everywhere around the world. So
Yeah,
with
just
that,
want to add. I just want to add, since you mentioned California, while I'm talking, water is traded in future market in the US and California in specific. That means the water is traded like oil and gold in the futures market. So you can imagine the crisis is very, as you rightly said, it's very global. And the warmer planet change has changed. I mean, cities were built in according to availability of water. Now if the water
yeah.
availability is changed because of a warmer planet, you don't necessarily these cities get the water they used to get historically. So yes, California is a classic example.
Yeah, I think yeah, that's a good point, right? I think if you like zoom out a little bit, I think if you see most of the civilizations, I think they came either in the river valleys,
Mm.
or beside like river systems, or they were along the sea, right, where like they were supported by trade. And
Mm.
today, like we take water for granted, but I think increasingly, as you said, like from your own personal example as well, and both of us live in Bangalore, we can see the impact in our own city, right? So. Uh, I think it is like coming up on the agenda for a lot of people, and I think a lot of people are not aware of the various systems that are there. So with that, I think maybe should we do like a demo, or are there any other aspects that you want to cover, Ganesh?
Yeah, I'll show you a demo. I'll also quickly
Maybe we
make.
can, in the interest of time, maybe we can show a few dashboards or how the dashboards look as well. So you can walk us through that as well. Yeah,
Okay,
like
sure,
somebody
sure.
put the data as well. Yeah.
Yeah, so as you can see, basically we stream the data and from the IoT hardware and goes to cloud, and you would be able to see this mobile and web dashboard. And so, as I said, mobile dashboard would actually give quick alerts. It also generates phone calls if they have not been able to take quick action. So there will be a quick pop-up coming onto that, and a web application also has these charts which says if there is a consumption going beyond certain limit, there is a financial implication also coming in, and it shows in red how much water is getting wasted, and what action to be taken. There is reporting and alerting that comes in to this dashboard. And not just that, it is also depending on industry specific reports are generated. We also have a very, I told you, we also give customized dashboard, right? For some very high big customers, we also put the geographical image of the locality, and we've been able to show the what do you say, water consumption at different points, and also give like notification at which location the water is getting utilized the most. So earlier to this, our customers used to go to all these places, take hand reading of water data, because that's required according to compliance. Now not only that, they get water data every 5 minutes, they also get this clicking of this link, I mean the pop, where there is excessive usage of water. So, and they have been able to take corrective action. So like this, where we have been able to have multiple points in our location where they can take action, right? And
Yeah, so I think this is really great because you can visually see, like, where water is getting sourced and where it's getting like used a lot. So you're right, I think, and I've also seen this, that like doing physical inspections is non-scalable, and only again, like, they're prone to human error. There are again, like, maybe it is there only for part of the time. Maybe some other industries run like 24/7. Like, for example, even the treatment plant, sewage treatment plant, or the effluent treatment plant might be running like 24/7. So
hmm,
yeah, so there is some amount of monitoring, and then like seeing it in one dashboard, and having that visual kind of input actually really helps, because that is how we actually think as humans, right? I mean, if you tell me the levels of the water, I mean, I probably can make sense, but I need to have some amount of context. But if you show me like visually and using color codes, like you're showing like green and red, like in terms of compliance, then I think it is also possible to remedy it much faster, which actually both has a huge environmental impact, but also has an impact on the bottom line, as well.
correct. See, I mean, not just that, right? I mean, what you mentioned is absolutely right, but there's also aspect that health. I mean, you can't take water data from some location which is has, difficult to jump and climb up. So there's a health aspect, safety aspect also, and
Absolutely.
so there is multiple aspect, and also these are the locations which are also required for your compliance needs to regulate your water consumption. You are taking water data only once a day, you would never know the consumption pattern, and that
Right.
way
Right.
you would probably even day during certain shift water is enormously utilized because of some behavioral aspect, right?
Yeah.
So
So we can't even
continuous.
optimize because you don't even have the data, right?
Correct, correct. So that's how we've been able to help our customers. And yeah, I mean, I'll just try to quickly see if I can show the this one dashboard also. So this is how it looks in real.
Okay.
Because of interest of time, I'll quickly jump through how it comes, and you're able to see the consumption. This blue is right now consumption happening, dark blue is the previous day's consumption, or you can even jump to any other day and take corrective action. You can go for today, this month, this week, any of this thing you can get. So there is also water level, I mean there is consumption at various this one, and there's also the water level uh, that, just a second, it's taking some time.
So yeah, so this is, I think, showing a flow through the system, right? Like how
Yeah,
much is
yeah,
like groundwater, how much is like utilized, and
available.
how much
Yeah,
is like collected back into the groundwater again.
yeah. And yeah, I mean, also there is this generate reports and all those things comes into this from the dashboard. The pop-up comes up in terms of our through this solution. So this is generally how we've been able to do. Comparatively, this one other dashboard I'm trying to open, but it's unable to open. But yeah, this is generally how we been able to help our clients.
Cool. So yeah,
Uh,
since you talked about
I mean, yeah,
startups,
yeah, please.
like clients, maybe let's talk a little bit about who are your users as well a little bit. Yeah.
Yeah, I mean, whatever we are today, it's all because of our customers, because they have helped us understand the requirement and we have solved their problems. And these are our major clients, key customers. We have our solution running in more than 50 customers, 100 plus location. And not just, I mean, it's in food processing, beverage, mining, metals, hospitals, textile. These are our major sectors that we have solved, even including buildings. We also implemented our solution to various buildings in Bangalore and software parks as well. Not just that, they have been able to give very glowing testimonial, and the Tata Steel Group has also Tata Steel has also done a press release about our partnership with them in solving their water related, and we are doing to multiple sites of Tata Steel and Tata Steel Mining and various other groups. And yeah, I mean, so that's where we have derived great this one from our customers. Yeah.
Cool. Yeah, I think this is great. Like, I mean, because it solves like a problem that we're facing and will increasingly face as we go ahead. Um, just want to, like, if anybody has any questions, please put them in the chat. We have a few minutes, so we'll take any final questions. And also, I think there is a link at the bottom. There is a learn module, like, how to build an early stage startup. So just as Ganesh has gone about, building his startup, starting as a single person founder and building the team, we talk about, different aspects of, building, whether it is building a startup, whether it's like building a team, raising funding, setting up your technology. So it actually takes you through the paces. And I think maybe I know that, Ganesh and FluxGen was also kind of featured in the Microsoft sustainability report as well. So it was highlighted there as well. Yeah, I think you have won many awards. So I'll leave it to Ganesh, to talk about the various award-winning work that you have done, and we'll stop at that if there are no questions.
No, thanks again, Vinayak. I think this was a great experience conversing with you, because we have been fortunate enough to win various awards. All the credit should go to my team. They have worked really hard, and we have won more than a dozen, and I have highlighted some six of them. And one this also gave us recognition in front of our customers. This also led to some grants, and we have also been able to learn when we, I mean, as we gain this awards, it's a responsibility on solving this problem becomes even more. Awards by itself doesn't mean anything unless we act upon our responsibility. So this was a great session. Thanks again for having me on this session. Happy to take any question if there's
We don't have any questions, but I think we're a little over time, so we'll probably stop here. And thanks, Ganesh, for like
any.
illuminating this aspect. As I said, like, we talk about energy and we talk about carbon capture and most of these other things, but I think something that really affects us, I think, is water. And basically, we just start to take it for granted, and we can't take it for granted any longer, both from a personal perspective, even from a and also from a commercial perspective. So thank you for, like, um, um, enlightening us on the different aspects of, water management, and how you're using technology to actually get a sense of, how water is used, how it is consumed, and how it's kind of recharged, right? So we cannot optimize, and we cannot say what we cannot measure. So I think measurement is the first step, and then, it was fascinating to see, how you're doing the alerting and using data science to kind of trigger different kinds of alerts to actually make the management much easier, whether it's like through visual or through mobile phones and notifications.
Thanks again, Vinayak. This was really a humbling experience. I really enjoyed. Thanks again. I thank all the audience also for being on this live, and love to connect and exchange notes in the future. Thanks again. Thank you so much.
Thanks, Ganesh. And for the audience, I think we will be back in another 10 to 15 days. So watch this space for another edition of Scale Up Thursdays, and hope to have you talk about different aspects of how technology is affecting our daily lives and how people are building on Azure to kind of solve like real world problems in various industries. So thank you so much, and over to you, Rashmita.
Thank you, everyone. Thank you. Have a nice day.